Many modern RF signals use frequency hopping techniques to reduce interference and improve security of the transmitted data. Real-time analysis makes characterization of these signals much easier than traditional swept analyzers. Let's make several quick measurements to start to characterize these frequency hopping signals. First, let's look at the entire span of hops in real time. With our persistence mode on, we can immediately see that there are 11 frequencies or channels in this signal configuration. We can also turn on the marker table. We can use the markers to measure the delta of the span, in this case 32 MHz, and the span between channels, which is 3.2 MHz. Now let's switch to the density spectrogram view. We can see the hopping behavior on this signal is in a simple triangle pattern. Or we can zoom in to measure the total FM deviation on each channel. Here we see an FM deviation of 970 kHz. We can also trigger on the power output here and return to the full span to view this signal in time using our PVT normal spectrogram view. Now we're viewing time in the main window and capturing each pulse. This is the power over the entire span, so it shows the pulse width of each event even though the underlying carrier frequency is changing. That's really the power of real-time spectrum analysis. This shows that each pulse is 3.2 milliseconds long, with one FM modulated pulse at each of the 11 frequency channels. So there are your techniques and visualization tools in a real-time spectrum analyzer for debugging frequency hopping signals.